Welcome to Real-World gRPC with ASP.NET. In this video series, we'll get familiar with how gRPC can be used in ASP.NET. We'll see how we can host and call gRPC services in .NET, maintain protocol buffers contracts, implement cross-cutting concerns, and more. In this first video, we'll see a high-level overview of gRPC itself, and in later videos in the series, we'll focus on using it in ASP.NET applications. RPC stands for Remote Procedure Call, which is a technology for executing procedures across distributed systems as if it was a local method call on a single machine. In RPC frameworks, the details of the network communication necessary to execute the remote call is typically hidden from the developer. gRPC is a cross-platform high-performance RPC framework originally created by Google and since open source. It is widely adopted in the industry for implementing service-to-service communication in distributed systems and for communicating between end clients and services. gRPC builds on top of HTTP2 as its transport protocol. It supports multiple communication patterns, including bidirectional streaming between clients and the server. It uses protocol buffers both as the interface definition language to define contracts and also as the default binary data format of the messages transported over the network. Client libraries and server stubs can be generated based on the Protobuf contracts. Given that gRPC is often used as an alternative to REST, which is a very well-known architectural style that most backend developers are familiar with, it is useful to see how gRPC compares to REST in various aspects. The data format of the request and response bodies for REST is typically JSON, and for gRPC, it's Protobuf binaries. REST services can be accessed via either HTTP1 or HTTP2. On the other hand, gRPC heavily builds on top of the capabilities of HTTP2, so it cannot be used with HTTP1. The API contract style of the two technologies are quite different. REST follows a set of guidelines which are centered around resources and builds on top of HTTP concepts, utilizing things like verbs and status codes to have specific semantic meaning. gRPC uses RPC style, where we can define services each with a number of methods, where each method can have an arbitrary request and response model. This approach is thus similar to how we would design the interface of a class in an object-oriented programming language. HTTP is only used as a transport mechanism, and its concepts are not used as part of the API contract. REST services typically don't have a strict contract specification, but open API contracts can be created upfront or dynamically generated from existing services. On the other hand, gRPC requires a strict contract specification to be created upfront using the interface definition language of protocol buffers. And finally, the communication pattern used by REST APIs is single request response, and if streaming or two-directional messaging is needed, typically another technology such as WebSockets is used. On the other hand, gRPC supports bidirectional message streaming between the client and the server. In the Protobuf contracts, we can define services which can have an arbitrary number of endpoints called RPCs. Each RPC has a single request and response model, which by convention have the suffix request and reply in their names. The models are used in two different ways. They are used during development by the gRPC tooling to generate server and client stubs to make implementing the services convenient and streamlined. This is a significant benefit of using gRPC compared to REST, as it can make the introduction of new services much easier, especially in a distributed infrastructure using multiple different technical stacks. And the code generation ensures the adherence to the predefined contracts and can enforce good practices when it comes to introducing breaking changes. The contracts are also used at runtime for serializing and deserializing the data when sending gRPC messages over the network. gRPC supports multiple communication styles. The simplest one is called unary, in which an RPC operation includes a single request and response. This is similar to the request-response model of HTTP1, thus it's the most typical choice when migrating existing REST services to gRPC. gRPC also supports a streaming communication style, which can be either server streaming, client streaming, or bidirectional streaming. With server streaming, the server can reply with a stream of multiple messages to the client's request. When using client streaming, the client can send multiple messages to the server and the server reply with a single response. And finally, with bidirectional streaming, both the client and the server can send multiple messages in a single interaction. When using streaming, gRPC utilizes HTTP2 to carry out the whole interaction over one single TCP connection, which can make the communication very efficient. In the next video, we'll see an example of how to implement a gRPC service and client in .NET with C#.